So starting with number 4, axis of symmetry, x equals 1. Vertex was 1, 3. The domain and range are written different, so I'll write those in. But domain was negative infinity to infinity. Range was negative infinity to 3. If you didn't get to certain ones, just make sure you have these written down and the table filled out. You can go back and graph it later. Questions on number 4? Number 5, axis of symmetry, x equals 3. Vertex was 3, 4. Domain was the same, negative infinity to infinity. Range was now 4 to infinity. Yes, should have. This part, we are going to put it back in when we come back. So, not at this moment, but when we come back, we'll do that. Number 7, because we did number 6, axis of symmetry, x equals -2. Vertex was -2, -8. Domain was negative infinity to positive infinity. And range was -8 to infinity. We'll go over the last 3 when we get back from lunch, as well as talk about calculator stuff. Make sure you have your calculator when you get back. Number 8, axis of symmetry was x equals 2. Vertex was 2, 7. Domain was negative infinity to infinity. And then range was negative infinity to 7. What questions do we have on that? Number 9, axis of symmetry was x equals -1. Vertex was -1, 1. Domain was the same. And range was negative infinity to positive 1. Have any questions on 9? And then number 10, axis of symmetry was x equals -3. Vertex was -3, 7. Domain was the same. And range was negative infinity to positive 7. Yes, Marta.
How do you tell the difference when range is negative and you're with a number?
If this starts with a negative, this is also going to start with a negative because it's going down. And domain is left to right, or I'm sorry, range is lowest to highest, so the lowest would be somewhere at negative infinity. So if it starts with a negative, it's going to start with negative infinity. If it doesn't start with a negative, it's going to start with whatever the number is. go to the next page. This one in your notes. So now we are given two graphs, and we're going to answer these questions based on these two graphs. So if we had to find the axis of symmetry of graph A, we don't have an equation, but we could look at where does this, what line would split this parabola directly down the middle? At what point? Two. That was at 3. No, the line I drew was at -3. So you don't have to draw that line, but if you wanted to do that so you could see at this point it would split this parabola in half, you could do that. So this would be x equals -2. What would your axis of symmetry be for graph B? +3. At, wow, that was not great. At +3, this would split this down the middle. So this would be x equals 3. For your vertex, you're looking at your lowest and highest point on these graphs. For graph A, what is your vertex? Yes, but it has to be in order pair. So -5 is your y value. What's your x? And then remember that your maximum is your highest point, your minimum is your lowest point. So is this a maximum or a minimum? Minimum. For number 4, what is the vertex of graph B? Three, 4. That point right there. Would this be a maximum or a minimum? Maximum. Okay. Now, for 5 and 6, domain is going to be the same for both. All real numbers, or -infinity to infinity. Your range, however, is what's going to be different. So for A, this is going to start at -5 and keep going up. And for range, this is going to start at -infinity and go up to 4, our highest point on our vertex. Questions about any of this so far?
For the range of 5, like it's a negative, but that's because it's in the y.
Yeah, so we're looking at lowest to highest. We would start at the lowest point, which is our -5 on our y-axis, and then it keeps going up. These are supposed to have arrows, they just look like dots. For number 7, now they're asking us to find the equation for the graph. We can eliminate 2 of them because we know that this faces up, so it can't be negative. So we can get rid of C and D. We could find which one it is one of 2 ways. One, put both of these in your calculator and see which one matches. So let's say we'll do one way and one the other. So in my calculator, I could put both of these. So y equals, and I could put these in. x, your variable, squared, plus 4x, I forgot what the last part was, minus 1. And I could put the other one in at the same time. Your variable squared minus 4x minus 1. Then I'm going to look at the tables. So second graph. And I know my vertex needs to be at -2, -5. So when x is -2, the one that's at -5 is the one that's my answer. So the first one, so where it's plus. I put that in backwards, but the one that was plus was the correct answer. Questions on that before we do 8? The other way we could do this, so again, we can eliminate 2 of these answers because B faces down. So we can get rid of our positives. And then if we wanted to, we could find the axis of symmetry by doing our x equals -b over 2a. Really, we only have to do it for one of them, because it will either be that one or it won't be, and then it will have to be the other one. So let's say we do our axis of symmetry for C. That would be a -6 over 2 times -1, or 6 over -2, which is -3. Going back to our axis of symmetry, this was positive, so that could not be our answer. Questions on 8? So that was us finishing the second lesson, the graphing aspects. This is the start of the third lesson, but we're going to keep using these notes for a second. Go back to the first graph. The third part of this unit is being able to find solutions or roots from the graph. So when we do that, we're looking at, does this parabola cross or touch the x-axis? Yes, it does. At one place right here. So wherever it touches or crosses the x-axis would be your root or solution. 0, x-intercept, all of those are interchangeable. But this one would only have 1, and we would write that as an ordered pair. Sometimes you'll be given these solutions in your table also, so be on the lookout for that. Or number 2, does this cross the x-axis? No. So if it does not, then you would have no solution. What about number 3? No, it does not. So that would again be no solution. Flip over to the next page for number 4. Your solutions are your x-intercepts, your roots, your zeros. All of those are the same thing. So if we find x-intercepts, those are our solution. So let's think about it like this. If we were solving this by like the square root method, we would get solutions at the end. Those solutions would be the x-intercepts that would graph through the x-axis. All of those are connected. Okay, number 4. Does this go through the x-axis? Yes. And here it goes through it twice, but it doesn't quite look like these are actually on the grid lines. The grid is also kind of hard to see. So to help us see that better, we're going to put this in our calculator. So if you did not grab that when you came in, make sure you go grab that. And we're going to put that into our y equals. So negative 2x squared plus 4 times your variable plus 1. But instead of going to your table, hit graph. So not second graph, just graph. You'll be able to see clearly that this does not go through grid lines exactly. We can still find the solution. We just have to use the calculator to do it. So what we're going to do is go to second trace. So we've done this before, but it's been a while, so this is to remind you on how to do this. We're looking for zeros. That's another word for x-intercepts. So go on to number 2. We can't find both of these at the same time, so we have to do one at a time. Let's say we're doing this one first. We have to pick a number that is to the left of this. Someone give me a number. Negative 3. Negative anything would really work. Okay. Now we need a number to the right of this, but that doesn't go past this one. So 1 would work. Now we have boundary lines. Once you have those boundary lines, you're going to hit enter. And it's going to tell you what that x-intercept is. Negative 0.22, let's round 5.
Did you put in the second number?
Which one?
So like when you're in the graph,
Like, how do we get this?
yeah.
We're going to do it for the other one. So hopefully that answers your question. If it doesn't, let me know. To find the second one, we're going to go back to second trace. Go into 0 again. But now we need a number that is left of this one, but that doesn't go past this one. And you could do 1. 2 would be kind of close, but you could do that one too. And we need a number that is right of this. Can you give me a number? There are a bunch. 4 works. So now that we have these boundary lines, we're going to hit enter again. And we're going to get 2.22 round to 5. Mara, does that answer your question? Okay, so which number were you trying to get? I'm still listening to you.
So we have to be on that, like flashy. Does it have to be on one side or the
That doesn't matter.
other? So just put in a number.
It is, you have to pick numbers left and right of the x-intercept you're looking for. We are going to do this again on a different problem. So far, as we've looked at solutions, we've had one that had 1, a few that had none, and one that had 2. When you're looking for solutions of quadratics, those are your only options. 1, none, 2. You get 3, something's wrong there. Also be careful because you could get 1 and it's supposed to be 2, or get 1 and it's supposed to be none, or any combination of those.
I think I never knew was that negative 0.9. What is it?
Hold that up. As soon as we finish this, I'll come look at that, but follow along with the next one. Maybe it was something that got put in there. For number 5, does this cross the x-axis? No. So this would be no solution. Number 6, does it cross the x-axis? No, so that solution would be what? No solution again. Number 7, does that cross the x-axis? How many times? Twice. So it's going to have 2 solutions. And again, these points are kind of hard to see, but I only know that those are the exact points because they're also given to me in my table. If they weren't given to me in my table, I would have to put it back in my graph and see what are the actual solutions. Moving on to number 8. Does this cross the x-axis? Yes. How many times? Twice. But these are not given to me in my table, and this one definitely looks like it's off the graph. So let's put this into our calculator and find out what those solutions are. We go back and change this equation to negative x squared plus 4x plus 3. I'm just going to change this instead of clearing it out, but you can clear it out too. So delete that. 4x plus 3. Go to your graph. You can see that these are both not on a grid line exactly, so we're going to have to use this method again. Second, trace. And then go into 0. And then we're going to begin finding one of them. So let's say we're looking for this x-intercept. I'm going to draw. We're looking for that x-intercept. So we need a number that is left of that. Someone give me a number that would work. What is the number to the left of this point? Negative 3 works. Put it in, press enter. Now we need a number to the right of this point, but that can't go past the second point. 3 would work. and hit enter. And then once you have your boundary lines, hit enter again. So that would be one of your solutions. Negative 0.64, let's round 6. And then let's find the other one. Same process, second trace. Go into 0. Now we're looking for this point. So we need a number to the left of this point that doesn't go past this one. What's the number that would work? 1 would work. Now we need a number to the right of this point. 7, sure. Now we have boundary lines, hit enter again. 4.646 would be your solution. Questions on that? For number 9, this is across the x-axis. Yes. How many times? 2. And here, these are given in your table. So your solutions are negative 2, 0, and 0, 0. And for number 10, this also crosses your x-axis twice. So we would again need to put this in and figure out what those are. Right, so put that last one in your calculator. Negative 3x squared minus 18x minus 20. Double check it in your graph just to make sure. These are in between 2 points, so we definitely have to find them. Second trace. Does not matter which one you find first. So if you want to find this one first, that's fine. We need a number that is to the left of this, but that doesn't go past this. Negative 7. And something in between here, I could say negative, 3. Then we would have boundary lines. We could hit enter. Negative 4.5 through 8. And then do the same thing for the other solution. Second trace, we're looking for a 0. But now we're looking for something to the left of this that doesn't go past this point. We could use that same number, negative 3. And and then something to the right. Really, anything would work. And then once you have those boundary lines, hit enter again. Negative 1.472. We went around that one. Would be your other solution. Do you have any questions on how we find solutions from a graph?
Guys, let me ask you a question. On a solution, what is the y value always on a solution? What's the y value? Zero. The y value is zero. That's the definition. Solution, zero. Y is always zero. On a quadratic function, is there a domain that's left out? Is there an x value that is not included in the domain? Every x value is included. From now, for all eternity, a quadratic function's domain is all real numbers. Nothing is left out. There is an x value forever. When you get to heaven, there will still be x values in your quadratic function. I may not be going to heaven, but you guys will.
On those notes I just gave you, fill this part out. This is so you have the actual definition of what we were just talking about. So we mentioned this definition before, like units ago in Unit 2. But specifically when we're talking about quadratics, we're talking about roots. Doesn't mean that they can't be interchanged, but quadratics, you think roots. So the point at which the problem intersects the x-axis would be our definition, also called zero solutions and x-intercepts. And then, as we were just talking about, if your parabola goes through your x-axis twice, you have two solutions. It goes through, not goes through it. If it touches it at one spot on the x-axis, that is one solution. And it will either face up or down. And then no solution would not touch the x-axis at all. There are 6 problems on these where you have to graph and then find the solutions. So you may need to have your other notes out so that you can refer back to how do we graph them. I'm going to switch pages for 1 second. I think on yours it says ignore, but once you get to this part, stop. You're going to do those 6 problems. If we have time, we'll go over them today. If not, we'll go over them next class. But work through those 6. Let us know if you have any questions or need any